Welcome back to a new video on our channel Steady Brains. Today in this video we are going to learn about chemical equations and reactions. Mainly, now let us learn about chemical changes and physical changes. What is a chemical change? A chemical change is a thing that one or more new substances is formed with new properties, then it is known as a chemical change. For example, making a curd. Second example, for making a curry. The best example is the respiration. If we take in oxygen, we release carbon dioxide. So here is a new substance formed. What is a physical change? That's correct. There may be the change in state or odor or smell, but there is no change in the property of the object. The best example is water is converted into ice and the ice is again converted into water. Now here are some examples for you on the screen. Now answer the things which are chemical and which are physical changes. Here are the examples. Number 1, rusting of iron. Number 2, melting sugar in water. Number 3, burning of paper. Number 4, melting an ice cream. Number 5, boiling an egg. Number 6, tearing of paper. Now answer which are chemical and physical changes. Here are the answers for you. The rusting of iron is a chemical change as rusting cannot be taken back. Number 2, melting of sugar in water is a physical change as it can be gained back by crystallization. Number 3, burning of paper is a chemical change as the ashes cannot be turned into paper again. Number 4, melting of an ice cream is a physical change as if you freeze it again the ice cream comes back. Number 5, boiling an egg. Boiling an egg is a chemical change as the egg boiled cannot be taken back. Number 6, tearing of paper. This is a tricky one. It is also a physical change as there is change in state but not in its chemical properties. Now let us see what is a chemical reaction. Chemical reaction is a process that occurs when two or more molecules interact each other to form a new substance. For instance or for example, take hydrogen plus oxygen, we will get H2O, which is water. Another example is iron plus water, which is Fe plus O2, will get FeO2, which is rust. Now, can you tell me what are the observations you see while a chemical reaction? That's correct. We can see four observations. Change in smell, change in state, change in color and evolution of gas. These are the 4 observations we can observe while a chemical reaction. Now, if we take hydrogen plus oxygen goes to H2O, means water. What is the thing on the left hand side and what is the thing on the right hand side? That's correct. Hydrogen plus oxygen is the reactant and water is the product. So we can tell that the left hand side the thing is reactant and the right hand side thing is the product. Now you guys tell me, what is a word equation? That's correct. A word equation is a chemical reactions which is expressed in words rather than chemical formulas to easily understand the reactants and products. Let's take the same example. Hydrogen plus oxygen goes to water. But some people have doubt if we write it as H2 plus O2, H2O. Then what is this? So for easy understanding we can write hydrogen plus oxygen gives water. Here is a small tricky question for you. Can you tell me what is the chemical code for a chemical reaction? That's it. Symbol is the code for chemical reaction. Now let us see what is chemical equation. If the chemical reaction is written in the terms of symbols and formulas, then it is known as chemical equation. It is quite opposite to word equation. Before we get into balancing the chemical equation and how to balance it, let's see what is law of conservation of mass. You would have learnt it in class 9. Just recollect it. That's correct. Law of conservation of mass states that an atom cannot be created or destroyed in a chemical reaction. So, the number of atoms on the reactant side should be equal to the number of atoms on the product side. Now let us see what is a balanced chemical equation. It is just similar to the law of conservation of mass. The balanced chemical equation is a chemical equation which has the same number of atoms on the reactant side should have the same number of atoms on the product side. So if, for example, if you have 3 chocolates on this side, then 3 chocolates, the same 3 chocolates should be on the other side. So these both are now balanced and we can tell it is a balanced chemical equation. Now let us see the steps on my screen how to balance a chemical equation. Let us now see how to balance a chemical equation. Here is an example and let's see the step 1. Step 1. The balanced chemical equation. The equation we took is Al plus O2 goes to this is the reactant and this is the product. Al plus O2 go to Al2O3. Al means aluminium and O2 means oxygen. Then step 2. Make a list identifying the atoms in each element. Now we shall make a list identifying the atoms in each element. Here in Al there is only one atom. If there is nothing here, it's just one atom. In oxygen or O2 there are 2 atoms. Here in Al2O3, in aluminium there are 2 atoms and in oxygen there are 3 atoms. Now we should multiply the number of atoms. Al plus O2 goes to Al3. Here Al 1 into 2. Here 2 aluminium atoms and here 1 aluminium atom. So we should multiply both of the atoms. We will get 2. And here in this oxygen we should multiply these 2 atoms and these 3 atoms. Then 2 into 3 is equal to 6. Here this side, here 2 atoms we should multiply with this 1 atom means 2. Here 3 atoms we should multiply with these 2 atoms. Then it is 6. Now here it is balancing. Now step 4. Place the coefficients in front of molecules. Now let us place this is known here the value we got is known as coefficient. Let's place it in front of molecules. The molecules means this one. Here if we bring the 2 beside to the coefficient of aluminium, it will come 2Al and 3. If this 3 comes up here to oxygen 3O2. If the product goes that side, then we will get 2Al2O3. Here 2, Al2O3. 2 into 2, 4. Let's balance it now. 2 into 2, 4 and 2 into 3 is equal to 6. Step 4. Check the equation and balance again. Here we balanced first time and now we shall balance it completely. Here the equation is 2Al plus 3O2 goes to 2Al2O3. Here Al has two coefficients but 0 atoms, but just 1 atom. Here Al has 2 atoms, so it is not still balanced. Let's balance it. Here if Al is balanced, or we should balance it, 2 into 2 is equal to 4. In this Al or aluminium there are 4 atoms, so we should multiply with this 1 atom. Then 4 into 1 is equal to 4. Finally step 6. We got the balanced chemical equation. 4Al plus 3O2 goes to 2Al2 plus 2Al2O3. Let us see if it is balanced or not. Here 4Al. 2 into Al2, 4Al. 3O2. 2 into O3. If it brings here and this 2 goes to atoms, 3O2. Here is the balanced chemical equation. Now let's see the types of chemical reactions. There are 7 types of chemical reactions. The first type is combination reaction. If one or more elements combine to form a new compound, then it is known as combination reaction. For example, if you take an element A and element B, if you both combine them, they form an compound AB. So, here is an easy example for you. take the colors red and blue. If you combine both the colors, then we will get the color red-blue. If we see in terms of chemistry, sodium plus chlorine, if we combine them, we will get sodium chloride. Now, let's get into the second type, decomposition reaction. Decomposition reaction is quite reverse to combination reaction. If you have a compound, we break them to get two elements. So if we take the last examples, if we have sodium and chlorine to get sodium chloride in combination reaction, here we will get sodium chloride. Then if we decompose it, we will get sodium and chlorine. It's just quite reverse to combination reaction. Here in this decomposition reaction, we have another type. It is thermal decomposition reaction. If any substance is broken down by heating or any change in the color or state by heating, then it is known as decomposition reaction. Let's take an example. Take a few pieces of ferrous sulfate crystals. Heat them up and note the color before heating. After heating, check the color of the ferrous sulfate crystals. You see the change in the color. So this is the example for thermal decomposition reaction. And the other two reactions are endothermic reaction and exothermic reaction from decomposition reaction. Endothermic reaction means the reaction which absorbs the heat or energy is known as endothermic reaction. The exothermic reaction is quite opposite to it. If it is releasing the energy or heat, then it is known as exothermic reaction. Now let us see what is a displacement reaction. Displacement reaction means when an element displaces or removes another element in the solution, then it is known as displacement reaction. Let's take an example. Fe, ferrous plus CuSO4, copper sulfate, goes to FeSO4 plus Cu. Here you can see that ferrous plus copper sulfate, if we both mix up, then the ferrous would take up the sulfate in that and we will get the product ferrous sulfate plus copper. Now let us see what is double displacement reaction. The reaction in which there are exchange of ions in the reactants, then it is known as double displacement reaction. This is the reactant side. If there is a change of ions, then it is known as double displacement reaction. Let's see this with an example. Let's take Na2SO4, which is sodium sulfate, plus BaCl2, which is barium chloride. If we product and transpose it, we will get BaSO4, which is barium sulfate, plus 2NaCl. So here in this reactant side we can see Na2 and Cl2. So this 2 is the ion. So it is taken as common and is written as 2NaCl. Sometimes in this double displacement reaction, there are some particles which are not soluble in the solution. These particles are known as precipitate. In the process in which these particles don't dissolve are known as precipitation. Now let us see what is oxidation and reduction or red-ox reaction. Oxidation. If a substance gains oxygen during a reaction, it is known as oxidation. For example, if you take copper 2Cu plus oxygen O2. If it is gained with oxygen, then we will get 2CO, copper oxide twice. Reduction. In a reaction, if the substance loses oxygen, then it is known as reduction. Take an example. If you have mercury oxide, HgO, if it loses oxygen, then it will be Hg mercury plus O2 oxygen. Till now, we saw oxidation reduction in oxygen. Now, let us see it in hydrogen. In the oxidation reaction, if it is losing hydrogen, then it is called oxidation reaction. If it is gaining hydrogen, then it is known as reduction reaction. Here is an example. Here H2S, hydrogen sulfide plus Cl2, chlorine. If we product it, we will get HCl, hydrochloric acid plus S, sulfur. Here in H2S, hydrogen is removed and we got HCl, which is sulfur. This is oxidation reaction. Here in 2Cl, we got the hydrogen is added, then it is HCl, which is known as reduction reaction. Here, if we combine oxygen and hydrogen to the redox reaction, we will get, if any substance gaining oxygen and losing hydrogen is oxidation reaction, and the substance which loses oxygen and gains hydrogen is known as redox reaction. Now let's see what is corrosion and rancidity. When a metal is attacked by moisture or air, it gets a green coating or some coating on it. For example, if a silver is attacked by moisture, we'll get a black coating. If it is attacked by copper, if the copper is attacked, we will get green color. So the corrosion usually damages our car bodies, railings, or any other items which are made of metals. Rancidity. When the food we eat have fats and oils. When these fats and oils are reacted with or oxidized, they are becoming rancid and their smell and taste also change. So to take out this oxidized, we used items such as antioxidants. Or if you keep or store the food in airtight packs, you can prevent them from rancidity. You know one thing? The chips packet we eat, the Lays or Kurkure, they are filled with air. You all think it is oxygen, but that's wrong. Oxygen is very reactive and the chips may go stale. So it is filled with nitrogen gas. Why? So nitrogen gas stops the chips from going stale, which is so hard and becoming rancid, stale. So the nitrogen gas stop the chips going stale and keep them fresh and clean. So what we have learned, you can see upon here. So guys, this is the video on chemical reactions and equation. Meet you in the next video, but don't forget to like the video, subscribe to Steady Brains and hit the bell icon. Please share this video to others so that they can get some knowledge of our channel. Thank you. Bye bye.